Hi YouTube. In the last video, we talked about signals. Signals are one of the core fundamentals behind motion canvas. Everything, essentially, any sort of manipulation, I should say, um, is a signal. So when you change your scale, when you get something, when you set something, initial value, those all use signals behind the scene, and they are fundamental. So we can see retrieving, updating, and then also a tween. We'll get to tween in a future video, but between tweens and signals, you basically have motion canvas. They are very powerful. And we looked at what you could do with the signal and how if there's another signal inside, if the second signal includes items from another signal or a signal above it, it will automatically detect that and will recalculate when it's being called if the value has changed. It is fascinating. They're lazy, they're caching, they cache, they track dependencies automatically. When I learned about signals, I'm thinking, why can't React by itself come with this by default? It is incredible. We also went over default values and how a default value can set the signal back to what it originally was, or it will set the parent or settle back to what its parent value was. We even looked at a complex example by just changing one value, which is the radius. Everything else changes. If you want to learn more, look at the last video. It is amazing. I am fascinated by signals. In this video, we're going to be going into effects. So effects let you observe changes to signals and react to them. Unlike signals, effects are not lazy. And what do we mean by lazy? Lazy means they're only calculated when the value is requested. So effects are recalculated when the value changes, not just when it's requested. So create effect runs the callback immediately after any of its dependents changes, and create deferred effect runs the callback at the end of each frame during which any of its dependencies changed. So if you're familiar with React, create effect kind of reminds me of use effect in React, kind of. They are useful for side changes such as modifying the node hierarchy or spawning background animations in response to changes in subsignals. When it comes to modifying the properties of nodes, refer to using signals. Effects are created using create effect and create deferred effect functions. The first argument specifies the callback to invoke. So in this example, we have a signal, which we set the initial value to 0. And then we also have create effect. So this will run anytime the signal has changed. So for example, we can have an unsubscribe create effect. So we do something and then we unsubscribe. So after creation, effects can be disposed of using the return function. Explanation. To understand the differences between signals and effects, consider this modified example from the signals section. So when we are talking about calculating the area of a circle, we had this sort of example in signals. Let's take a look at it now as an effect. So we still have our signal. That hasn't changed. We still have our area. That again hasn't changed. Create effect area. So anytime the radius is changed, we're going to automatically update the area. And so we can see that, hey, area is recalculated. We update the radius. Area recalculated because create effect ran, which automatically called area. And it will call it, and because area is now a create effect item, actually I think this might be a typo, maybe not, then we have every single time we call radius, because area is inside of create effect, it loses its laziness essentially. This time the area signal is invoked inside of the effect. Okay, so it wasn't a typo. What this is saying is every time radius gets changed, create effect changes that detects that there is a change in area because there is a change in radius, and every time that this changes, this gets kicked off and then reprints out area. In this time, the area signal is invoked inside an effect instead of being called directly. Now whenever the radius signal changes, the effect is triggered, which recalculates the area signal instantly. This is a compromise. On one hand, we can now redirect changes to immediately without having to invoke the signal each frame. On the other hand, all dependencies of the effect are no longer lazy. Normally, this shouldn't be a problem, but if dependencies of the effect changes often and are expensive to calculate, this may affect your seeking performance. What is seeking? Moving the dial, like if I pause this, moving this to 1 second, 2 seconds, that's seeking. It won't affect the actual production of the videos. Deferred effects. If your effect references multiple dependencies that change often, you can use create deferred effect. So if your effect references multiple dependencies, you can just wait for all those effects, those changes to happen, and then at the end of the current frame, do the effect. This way, the effect is only executed once, even if multiple dependencies change throughout the frame. The downside is that the side effect caused by the deferred effect is not immediately visible. They will become visible after the current frame generator step is finished, but before the rendering starts. So in this case, we have A and B. A is 1, B is 2. We have your effect, which is an effect evoked, A plus B, which would be 3. So your value is set to 3. Your third value, A plus B, your value is set to 3. If A is 2, this effect will be 2 plus 2, would equal, of course, 4, and this would be 4 as well, but this would automatically change this to effect invoked, value is set to 4, effect evoked, value is set to 5. This still says 3. So value is 5, deferred value is 3. We're yielding to have another frame, and now the deferred value is 5. A complicated example. Following the example, it demonstrates how the effect, how to use the effects to automatically update the node hierarchy so the amount of circles displayed matches the value of the count signal. So if we start at the very beginning of this animation, Can I scroll? I cannot. That's fine. So I look at my imports. Okay. So we start with 0. So we have 0 balls. So if we watch this again, we start with 0 balls. We get 1, we get a bunch, and we start going down by 1. So we have our container reference of type layout. We put our layout in here. It's an empty layout. And we have our circles array. Circles array it's a circle array equals array. We create an effect. Target count equals math.round count. Count just gets the values of what we have. In this case, it's 0. Create signal really sounds like a state in React. Circles.length is I. And then we have target count is whatever our count is. So at first it's 0. So is I 0 less than or less than 0? If so, we skip these and we remove any extra circles. So then we set the count to 1. So if we look at this again, we start with 1 circle. And so we set the count to 1, this count, because we are referencing count in create effect. We go back into here. Target count is now 1. Circles.length is 0. 0 is less than 1. So we create a circle. We then push the circle in the circle array. Container.add, so we add a circle to the layout. And then we spawn a circle. So we add a circle, an invisible circle, and then we change the size of the invisible circle to 80. And we do it in 0.3 of a second. Then we remove any extra circles, which there are none. Okay. We wait for 1 second. We change it to 6. So if you look at this, we have 1 circle. Then we changes it to 6 circles. Then we change it to 4 circles. And then we go back down to 0. Okay. So then we wait 1 second after the 6 are done. Then we go down to 4. That's why 6, 4, and then we go down. So then we go down to a count of 0 in 2 seconds. So our count that we have, originally it's 1 real quick, 6 real quick, 4 real quick, 2, 0 in 2 seconds. So that's why it's you see the last 4 pop off as slowly as they are. And so this is what happens. Hope that makes sense. If you have any questions about this or need a better explanation, leave a comment down below. I will answer it right away. And until next time, I will see you later. In the next video, we'll go over references. And until then, have a great day and see you in the next one.